Yes, thank you, Antonios, to give me the floor. Good morning to everybody. I have been asked to introduce as a first talk for that session, to introduce a little bit the way of controlling Aedes invasive species in practice on the field. So that's a little bit a more general presentation, less technical, but it aimed to give the basis and to draw the context for the different intervention. And yes, I made it with Rubén Bueno Marí, who is working in Spain with Lokímica. He was the past president of EMCA, so that's why, and I'm the current active president of EMCA, the European Mosquito Control Association. That's why we made that together. Okay, so for a few words about the context. So there is a change in the perception of the pest and the vector control. In the end of the 60s, most of the vector-borne diseases were not considered anymore as a major problem in Europe. It's a European context. So the control programs that did exist in the past in Europe, they were huge programs against malaria or against Aedes aegypti also, but that's a bit at the early 20th century. They stopped progressively, and with decrease of funding, the disappearance of the public health specialists. And nowadays there is a re-emergence of spread of vector-borne diseases, mosquito-borne disease in particular, in new areas or areas that had vector-borne disease before, but not for a period. And there is also a change of concern about the side effect of the pesticides, which was not the case earlier. And the legislative context, of course, has changed. The regulation has changed, so we have now much less biocides or active substances that are available for mosquito control. So there have been some recommendations by many authors and by WHO in particular to better exploit the potential of vector control for the disease prevention, and that's in general. And this by giving more importance to multiple measures with an integrated vector management. So what is an integrated vector management? It's a rational decision-making process for the optimal use of the resources for vector control. So that's the definition from WHO. That means that you have to consider the efficacy of the methods you are using, the cost effectiveness, the ecological soundness, which is now important more and more, and the sustainability. So what can you do for long-term, these efforts that you can maintain for several years? And this can be achieved with advocacy, legislation. This has all to be adapted. Social mobilization is an important part of the invasive vector, of the integrated vector management. Collaboration with different sectors. So not only the health sector, but also environment, agriculture, economy, maybe, because it can be have some impact on the economy, negative or positive. It's an integrated approach, so you have an integration of all these methods, and it should be based on should be used on evidence-based decision. So you need to prove on the field that your actions are effective to be able to continue and to complete with other ones. And of course, it will need a lot of capacity building. We cannot just start with the basics. We need really professionals. Sometimes it's sleeping a bit. So why do we need to implement mosquito control, in particular for the Aedes invasive ones? Because of nuisance, of course, because of bacterial risk, and in case of epidemic or outbreak of epidemic of mosquito-borne disease. So they can be different aims, because one starting to define the control campaign, you need really to define the aim, because according to the aim, you will choose different methods. So for the invasive mosquito species, you can first to prevent the establishment and spread. You can aim at eliminating an established population. You can aim at suppressing a population to reduce the nuisance, So the talk of Norbert was a good example, because at the beginning they aim at elimination, but now they just want to suppress the population because they cannot achieve the aim anymore, the elimination anymore. And you can also prevent pathogen transmission. And of course, you can have two aims together as well. Yeah, thank you. And so according to the aim, in practice, you can reduce the number of vectors. That's in most of the cases. In the three first cases, you can reduce the number of vectors, but you can also aim at reducing the longevity of the vectors. And for preventing pathogen transmission, there you can reduce the contact rate host vector. So one arrow is missing. I mean, reducing the longevity of vectors is important when preventing pathogen transmission. But you can also work with reducing the the contact rate between vector hosts. So the methods will be different according to these three categories. And as for the tools, there are a number of tools. There are biological tools. The copypot is a good example, chemical tools. Abate is not possible anymore, but pyrethroids against adults, for example. BTI is a little bit in between. It's an insecticide, but it's of biological origin, but you can put it, people often put it in biological, but it's in fact in the middle. You have physical or mechanical actions, environmental actions, and source reduction, of course, is a method which is important for the Aedes container breeding in particular. Yeah, next. And this is a graph from a paper from Baldacchino from 2015, where you have, according to the cycle of the mosquitoes, you know it, you have different control methods that will apply, like BTI and BS, or Bacillus sphaericus, or spinosad, or other oils can be applied at the larval instars, also insect growth regulators. Then you can have other methods against adults, so pyrethroids, so chemical methods, but also the sterile insect technique is at the mating level. So there are different methods at different stages. So the question is then where to apply one method, when and how. Next one. And what we have to consider at the beginning is that the life traits, they do advocate for some methods. The most vulnerable stage of the mosquitoes is the aquatic one. They are located at precise places. They cannot escape. If you treat larval breeding sites, the larva will not escape. And the aerial phase is, of course, more difficult to target, because the adult mosquitoes can fly, they can hide in the vegetation, in a building, or at some places. They disperse in the environmental space. The next one. Aedes aegypti depends on feeding on human blood and has a small flight range. That's a general consideration. So it can also be targeted in or around the houses. There are a number of experiments, mainly in the Caribbean, where they suggest, for example, to open the windows when they do a spatial spraying, because a good proportion of the Aegypti population is staying indoor. This is not the case for Albopictus. Even they can enter for biting, but they will not stay on the walls inside the houses. So it's better than to close the windows. The other invasive mosquitoes feed more on mammal birds. Well, more. They feed also on human, of course. Albopictus is a good example, but they can feed on mammals, birds, reptiles, according to the availability of other hosts. So then we might target other environments, not only the human settlements, but also the surrounding and maybe even outside the settlements. Next, please. So as for reducing the number of vectors, the baseline is the larval control. That's what we usually suggest. It's limited by the accessibility of the habitats, the availability of active substances in adapted formulations. So here we have chemical control, or biochemical control, that's the spatial pulverization of larval insecticides. BTI, but also mineral oils, IgR, hormones. They are not a number of, they are few in active substances that are allowed currently in Europe, but it's, yeah, that's the most common usage. Next. We have strictly biological control. That means pathogenic parasites, predators like copepods, entomopathogenic bacteria. Bacillus ferricus is making his cycle in the breeding site. So that's a real biological control as well. So it maintains the cycles and produces the pathogenic molecule in the breeding sites for several weeks. And the next. And then we have environmental or mechanical control. So environmental is more adapted for the wetland mosquitoes, for example, where you can really manage the water level in the wetlands to reduce the production of larvae. But here the environmental is mechanical because you can destroy or evacuate and destroy a number of breeding sites, not all of them, of course. And you can also cover some water containers. So there are a number, usually when they do door-to-door campaign or community participation, they suggest to put a net on the rainwater barrels in the gardens, for example. Next. And lastly, you have genetic control. So that includes SIT, but also other modified, genetically modified techniques, Wolbachia or other ones. Next. And then the other step, reducing the longevity of the vectors. So that is recommended as an emergency intervention for adult, because this is adult control. So it's limited by the economic and the environmental cost. When you target adults, you cannot be selective as you can be with larval control. So if you use pyrethroids, they will be active to a lot of a large spectra of insects. So you can handle a little bit these aspects by spraying at a certain time and at a certain place. That's what Gregory was explaining yesterday. So this could be done by indoor residual spraying. So that's not the best method for this Aedes species, but it's sometimes used for Aedes aegypti. But it has been used for the malaria mosquitoes, because the malaria mosquitoes, they really bite indoor and they stay indoor, they rest indoor, so they can be controlled with residual spraying. Residual spraying means you spray on the walls and the insecticide is sticking on the wall, and the mosquito is contaminated when it lands on the wall. So it's not in the air inside the room. Yeah, that was for the intradomiciliary spatial spraying. That also includes the intradomiciliary includes also the surrounding of the house. So it's the housing and the focal spatial spraying. So that's what they do in France around the case. So they do a focal spatial spraying. I don't know exactly the size, but between 100 and 250 meters around the location of mosquito-borne disease case. Next, please. And then we have the mechanical control. So there are a lot of, not studies, but proposals of mass trapping. So there are few real studies that you can find in publications that demonstrate, that have evidence of a reduction of mosquito population with mass trapping. That's one example. Yeah, can you, the next one, please? That's one example of paper. It's only one I found, but I didn't make a systematic review. But there are a number of companies that suggest new traps to control and to make barriers against the mosquitoes, and in particular against the tiger mosquito. But this has to be taken with caution. But it could be for the future. It could maybe be some complementary tools that we can exploit and investigate. Next. And then the third action was reducing the contact rate between the host and the vector. So that's the personal protection. That's what is suggested by the health authorities during an outbreak of West Nile or during an outbreak of dengue and chikungunya. there are two methods. You can avoid the mosquitoes. That means eliminating the potential larval habitat, of course, with community participation, but also avoiding areas where the mosquitoes are known to be active, or the timing where the mosquitoes are active. And then you can protect yourself from mosquito bites by insect-proof clothing, by repellents, by mosquito screens or bed nets. That's more for the malaria mosquitoes, but if you have Aedes aegypti and you don't want them to enter, you can use screens on the windows, for example. There are a number of tools that exist. For the repellents, these are considered as biocides as well. So they are 5 molecules that are considered or recommended by WHO as effective, but then you have a large number of other ones that are less effective, but that can be used in some conditions. Next one. So what are the challenges that we face when working with Aedes invasive mosquitoes? So the main one, we already heard about that in several talks yesterday and even this morning, is that they are cryptic habitats in urban environments. So they are a huge number of various possible breeding sites in the environment. Next one. And the problem is that they are not accessible enough. So only a limited percentage of these habitats are accessible for the treatment or for removal and so. What we also consider is that eliminating an established Aedes invasive mosquito population is almost impossible, and it's very costly. It needs a huge effort. I did some attempt in Belgium with Aedes japonicus, which is not the most productive species. We were considering having eliminated it for 2 years, but then they found again some specimens at some places. So they might have been, according to the genetic results, they might have been new introduction, but also probably some survival of specimens in tree holes in the forest or at some remote places. And then after a while, the population reappears because the number of specimens is still there. So it needs a really pressure for several years to really achieve eliminating. And that could be maybe aimed at the areas at the limit of the distribution area of this species, but probably not in Southern Europe, where the climate and the environment is very favorable to these species. So controlling around the mosquito-borne disease cases to avoid further transmission, that's really the target during outbreaks. That needs, there we have a need for targeted adult deciding, and that's the case where we suggest this adult deciding. And the next, and of course, what is also challenging is to adapt the spraying technique and to the target, to the breeding sites that we are facing, and to search for alternative and new control methods to complement these classical techniques. So you had a previous talk about that, but I made a short list of what is existing. Yeah, the next one. Yeah. So there is under development, there are some tools like mosquito suppression or vectorial capacity control. So there are several methods based on Wolbachia infection. It's a Wolbachia that exists naturally in mosquitoes, but not in Aedes albopictus. So they took the one from Culex pipiens to put it in Aedes albopictus, and they are, according to the Wolbachia strain and to the mosquito species, you can achieve sterility or a lower vectorial capacity for a pathogen. There are also experiments on mosquito suppression with genetic manipulation. So there is an Oxitec strain of Aedes aegypti that has been released at some places to test and to achieve this aim. So far it's not done at a large scale. It's still experimental or pilot development. That what is recommended by WHO at this stage. And then we have the suppression through sterile insect techniques. So that's now ready for implementation. You had a good example before for Germany. So it's a mass release of sterile males. Next one. And they are also suppression of the mosquito population by using novel vector traps. I presented one before, but that was for creating a barrier. So really for suppressing a vector population that's not yet ready, but it's under development. And also using attractive toxic sugar bait, that's another method. We didn't find any speakers for that session, but that's something that could be explored for the future as well. So the principle that you have sugar bait with a toxic component and the mosquito is coming to feed and them there on this sugar bait and they die from the toxic, the poison that is there. Next one. So to summarize, the rational control of Aedes invasive mosquitoes, it relies to complementary methods with an integrated vector management plan. So you don't need to have all the methods together, but at least you can select a number of methods, because using only one method you will not achieve your aim, most probably. So it should combine efficacy and sustainability, and you may for sure clearly define the target and the aim when choosing all these methods, and select the method that are the best adapted to the local context. So that relies to the legislation, but also to the perception of the population for one method more than another. For all these new technologies, for example, there are a lot of communication that has to be done. I mean, the genetically modified organism is a delicate subject. So if you want to implement it, you really need to have the agreement of the authorities, but also of the community. Otherwise, you will have problems. Even for applying in adult deciding, it could be an issue when spraying adult deciding at many places. Next one. So when selecting the different methods, there are a number of criteria that you can assess. So first, to check if it's efficacious in the local settings, if there is risk for human or for the resident, if there is a risk for the environment, according to the methods. The next. Of course, you have to assess the cost. The funding is not unlimited, so you have to assess the cost of your method to have something that is sustainable for your team. Is there evidence of insecticide resistance? That's an important component when using adulticiding or even larviciding, not for the BGI, but for others. For the BS, for example, the Bacillus ferricus, you need to assess and to manage the resistance. Are the methods acceptable for the communities? Next. What would be the role of the community participation in your program? And is it consistent with the current government policies? And one more. And is there an efficient implementation and infrastructure that allows to apply all the methods that you are choosing? And of course, the sustainability of the mosquito control on the long term is one important aspect to consider. So it's not exhaustive. Maybe there are other questions. For sure, there are other questions to address when choosing the method, but these are examples and guidelines to next slide. So I hope that was clear. I'm pleased to invite you to welcome MK. As president, I would be happy to welcome you as member. So on the website, you can find all the information and the activities. We have a journal, the Journal of the European Mosquito Control Association, which aims to get well reviewed in the future. So please submit articles to our journal. And there is a conference that will happen in Vienna in early October, where you are also welcome to attend. And thank you for your attention. There are just a few references about integrated vector management guidelines that can be helpful if you want to go deeper into the project. Thank you.